In this video, we're going to show that if m is a common multiple of a and b, then the least common multiple of a and b divides m. This is a theorem. If you like seeing theorems being proved, subscribe to my channel. I have hundreds and hundreds of theorems and corollaries and lemmas which I've proven so far. Subscribe to my channel if you like this type of mathematics. Theoretical, pure mathematics, where we don't accept anything here on this channel unless we prove it. Stop accepting things that your teacher tells you is true. Doesn't matter if they're right or not. You need to prove it for yourself. That's what math is all about. Again, if you like math like this, subscribe to my channel, hit the like button, leave a comment. For now, let's get right into the proof. How about we define t to be defined to equal the LCM of a and b. Now, why the division algorithm keeps coming up, by the division algorithm, m can be written as qt plus r, where of course r is between 0 and t, and it can equal 0. Okay. Now, I want to show that r is a common multiple of a and b. That is it. I want to show basically that r is 0. If r is 0, then m will equal qt, which implies that t divides m. And t was the LCM. And that is, after all, what we want to show. Okay. So, assume for a moment, assume r is bigger than 0. Either r equals 0 or r is bigger than 0. So if this assumption turns out to be wrong, then r must equal 0 and the theorem follows. Okay. So rearranging, we have r is equal to m minus qt. But we're told that m is a common multiple of a and b. M is a common multiple of a and b. Also, t, being the least common multiple of a and b, is a common multiple of a and b. Well, if you subtract two common multiples of a and b, like we're doing right here, well, let me state that that implies that qt is a common multiple of a and b. So if m and qt are both common multiples of a and b, m is a common multiple, qt is a common multiple. But this implies that m minus qt, the difference of two common multiples of a and b, is also a common multiple of a and b. So this here is a common multiple of a and b. Only there's one good thing about it, is that's r. So r equals m minus qt is a common multiple of A and B. But where is it? Right here. Right here. R is less than T. But R is less than T. Now, that's a contradiction. This can't be, since T is the least common multiple of A and B. So that implies that our assumption is wrong. That implies R equals 0, which implies from up here that M is equal to QT, which implies that T divides M, and for completeness, T was the LCM of A and B, which divides M. And that's the end of the proof. Basically use definitions. I use the division algorithm and some divisibility rules. If two numbers, if the difference of common multiples of A and B, or even two common multiples of just A, their difference is also going to be a common multiple of A. If you like videos where you see theorems and lemmas being proved all the time, I have hundreds of them on my YouTube channel. I'm closing in on 500 proofs. So if you like things like that, subscribe to my channel, hit the like button. As always, I hope to see you in the next video. And most importantly, keep watching and learning.